Welcome to video 3B. We're still working with some trigonometry and we're going to be what we call solving right triangles, but we're not going to entirely solve them. Actually, to solve a right triangle means to find all its missing sides and all its missing angles. We're just going to find singular missing sides and singular missing angles. So let's write find missing sides and or angles. And we're going to use our trig ratios to help us out. So remember our trig ratios. They are SSGeometryS2 Video3B. And let's go over here and let's split this into two pieces. Finding missing sides. How do we do that? Well, first thing we do, let's go draw one so you can kind of see a little example here, is we will be given an angle measure. Suppose it's up here and I tell you this is 61 degrees. There's going to be some side missing and some side given. Here's what you do. You go and grab the trig ratio from over here that deals with those two sides with regards to this angle. This is adjacent to the angle. This is opposite the angle. This is a tangent problem. So what I do is I say tangent. I think it's better to put an example here and just work one out. I say tangent of the angle I know is equal to opposite over adjacent, and I'm solving for x. What you always are going to do is multiply both sides by the denominator of this fraction. If it's a number, you multiply both sides by a number. If it's a variable, you multiply both sides by it. And I get right here. And then to solve this for x, tangent to 61 is really a number, and you could go to your calculator and write it down and round it. But the more we round, the farther off we are. So on your calculator, I'd prefer you just did 14 divided by tangent 61. Now I'm not going to bring my calculator up this time because I really want you to know how to work it. I'll talk you through it, but you need to get a calculator because on the test, if you come up to me and say, I don't know how to work this calculator, I'm going to send you back to watch the video. So let's go take a look. I've got 14 and I'm going to hit divide by tan 61. Remember to make sure that calculator is in degree mode. So hit your mode button and hit degrees. When you do that, you get a 7 point. And let's round to the 10th, shall we? About 7.8. So make sure you can get that on your calculator. If not, come up and see me. I will certainly answer it if you're struggling in the notes. On the test, I won't. I'm going to say you're going to have to hand me that test back and go back and watch the video prior to this one where I showed you how to work the calculator. To find a missing angle, it's a very similar approach but different calculator entry. What's going to happen on here is they're going to give you two sides. Maybe this is 15 and this is 18. And it's going to say, what's this angle? Let's give this angle a name, like W. You're still going to, again, classify these sides with regards to angle W. This is opposite. This is the hypotenuse. Which trig function deals with opposite and hypotenuse? You lock and load it. This is a sine problem. The sine of my angle, which I don't know the angle, is equal to opposite over hypotenuse. For me to get the angle back, this is where on my calculator I use that sine inverse key. I say my angle will be the inverse, sine inverse of 15 over 18. And again, make sure you're working that calculator. So I'll talk you through it. You're going to hit second, then you're going to hit sine, and then you're going to hit 15 divided by 18, enter. And you should get about 56.4 degrees. All right, let's go practice. Here we go. Find the missing angle or the missing side. This one's a missing side. I classify. Here's my 72 degree angle. I am adjacent. The one I want to find is the hypotenuse. This is a cosine. So katoa. So I say the cosine of my angle is equal to the adjacent side over the hypotenuse. I multiply both sides by the denominator of the fraction, and I get x cosine 72 is equal to 6. To isolate x, I divide both sides by what's in the way, in this case, cosine 72, which is a number. I just don't want to go to my calculator and find it. And I will go to my calculator and I will enter 6 divided by cosine 72. And I'll round to the tenths, and it's about 19.4. It's as easy as that. It's kind of fun. I like these. So the next one, let's go take a look at what we've got. We've got a 24-degree angle. We're looking for the opposite side. We know the adjacent side. So TOA. This is a tangent problem. TOA. So the tangent of my angle in question is going to be equal to the opposite side of the angle over the adjacent side to the angle. I multiply both sides by the denominator of the fraction. And in this case, I get 12 times tangent 24 is equal to x. So now I go to my calculator and I do 12 tan 24. And my answer is about 5.3. It's an approximation. We're rounding to the tenths today. All right, let's do another one. These, by the way, are optional. We're not going to do those for summer school. So you can go ahead and skip that set of notes, but your worksheet for 3.4 has word problems on it. So when it says go do worksheet 3.3 and 3.4, when you get to 3.4, before you move along, I'm going to do the odds for you. So go to 3.3, and then on 3.4, I'm going to do the odds for you. And here we've got some word problems, and you like to freak out with word problems, but these are easy. You just need to make sure you draw the triangle first, and then we just solve them like we just were. So let's go take a look at what we have. We have a kite flying. He lets out 300 feet of string, making an angle of 38 degrees with the ground. So here's my 300 feet of string. Let's go put a 300 on there. Here's the ground. These will all make right triangles. And the question is, how high above the ground, let's go make a fake kite here, how high above the ground is the kite? So what I do is I'm going to call that x. I'm going to go through that whole process again. I've got my 3 trig functions, sine, so, cosine, ka, tangent, toa. I'm going to classify these. That's opposite the angle. This is the hypotenuse. I go grab the trig function that deals with those 2 side lengths, and I set it up. I say the sine of my angle is equal to opposite over hypotenuse. I multiply both sides by the denominator of the fraction, wiping it off on the right-hand side, leaving just x, which is what I'm looking for. And then you go enter that on your calculator, which you can do on your own. A straight road to the top of the hill is 2,500 feet long, and it makes an angle of 12 degrees with the horizontal. This is horizontal. Find the height of the hill. Same process. Opposite, hypotenuse. Once again, I've got a sine set up. Sine of the angle in question is equal to the side opposite it over the hypotenuse. I multiply both sides by the denominator of the fraction. Cancels off over here. So I end up having 2,500 sine of 12 is equal to x. And I will not sign off on this unless you wrap those up. I want to make sure you can use your calculator, so I'm purposely leaving them undone. I need you to go get that on your calculator. Again, make sure you are in degree mode. A wire is attached to the top of a pole. Here's my pole. And it reaches a stake 20 feet from the foot of the pole. So here's my 20. It makes an angle of 58 degrees with the ground. So here's 58 degrees. Question is, how long's the wire? That's over here. So let's classify these. Adjacent, hypotenuse, right? So which trig function do I know that deals with adjacent and hypotenuse? And that's the cosine function. So I'm going to set that up. the cosine of my angle, in this case 58 degrees, is equal to adjacent, 20, over hypotenuse, don't know it. Multiply both sides by the denominator of the fraction. And I get x cosine 58 is going to equal 20. To isolate x, I divide by what's in the way. So I'm going to divide both sides by the cosine of 58 degrees. And you go do that on your calculator. And again, I will not sign off. You will not have access to the test. You will not be able to move on unless you go calculate that. And number 7, we've got a 25-foot ladder. There it is. Bang, bang, boom. And it's leaning against some building. The ladder's base is 13.5 feet from the building. The ladder is 25 feet long. Find the angle that the ladder makes with the ground. So let's give that angle a name. You can call it x if you want, or a for angle. A lot of times in higher levels of math, we call our angles the Greek letter theta, but go ahead and call it x because you're probably comfortable with that. And again, we go through that same process. We need to classify this side with regards to the angle, and that's adjacent. We need to classify this side with regards to the angle, and that's locked and loaded as the hypotenuse. So which trig function deals with adjacent and hypotenuse? The answer is cosine. So the cosine of my angle, no clue what it is equal to adjacent over hypotenuse. For me to attack that angle, I basically need to undo cosine. And to do that, I do cosine inverse. So x will equal cosine inverse of 13.5 over 25. And then again, you go to your calculator. Instead of hitting cosine, you hit second cosine. And then you do 13.5 divided by 25, enter, and it'll tell you what that angle measure is. So that's the end of 3.4. When all of it's signed off, you'll have access to the test, and we'll start a whole nother unit. It's been a good one.